We're going to construct unlabeled graphs of sine and cosine functions based on a circular model. The circular model consists of a circle with an x and a y coordinate system centered with the origin at the center of the circle. Now, the first thing we want to do to construct an approximate graph is mark off points around this circle. We're going to start here, and we don't have to start here. We can start any place, but I'm going to start on the positive x-axis. I'll mark this point. Then I'll mark points at equal distances around the circle. Now I'm just choosing pretty arbitrary distance here, and I don't know that my markings are really completely uniform in their distance around the circle, but let's just pretend that they are, and I can see that they aren't really uniform. I've got 1, 2, 3, 4, and almost 5 markings here. I've got 1, 2, 3, 4, and it really looks like I've got 5 markings that would span from here to here. So it's not completely uniform. It's not a perfect marking, but we can still get the idea. Now, from each of these marks, I'm going to project the point over to the y-axis. Now, by projecting the point over to the y-axis, I mean I draw a line from the point to the y-axis at a right angle to the y-axis. Okay. Now I can do that with points in the second, third, and fourth quadrants, but right now I'm going to stick with the first quadrant. And of course, the projection of this point is going to be here at 0. So we have these projected y values. Now, if these are equally spaced, I can construct a graph as follows. I start here, and I space points equally along this axis here. So this would be an x-axis, just like this is an x-axis. This axis is not thought to be the same as this axis. As a matter of fact, we'll often label this axis by theta, by an angle. And so I'm not even going to specifically label this axis as x or y or anything else. But here's our axis, and here's a perpendicular axis. Now, for the first point, the horizontal coordinate is going to, well, it's going to match this coordinate. And let me back up. Let me say that what I want to do along this axis, and it's what I was about to say and got sidetracked, is I want to mark points at equal distances along this horizontal axis. And hopefully I'm marking enough points that I can match them up with the points that I've drawn around the circle. Okay, don't know if I have enough. I can always extend the axis. Okay, so this point on this axis will match this point. Now, this point is going to represent what we get here. This point is going to represent what we get here. And my vertical coordinates are going to match the y values I have on the circle. So vertical coordinate here can match the y value, and actually I can go ahead and use the same scale here that I have on this y-axis. It's not necessary to do that, but I can. So this point would be here, this point would be here, this point would be here, this point would be here. Okay, now I'm going to match this coordinate with this y value, of course, giving us a point at the origin of this system. Then I'm going to match this second point with the y coordinate at this point. That's going to give me a point here. Then this point is going to match the y coordinate of this point. And that y-coordinate is here, so I get this. This point will match the y-coordinate of this point. This point, the y-coordinate here. And then we can continue around the circle in this manner. Now I'm going to draw a few more projection lines, and we'll do the projections for the second quadrant. Now I've put green X's along the y-axis at the points to which these 5 points here project. So I have a point here, 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 and here, and of course the projection lines through here. Now I'm going to mark the same coordinates over here. I'll do that off camera because there's no need for you to watch me. You ought to make your own markings, sketch your own picture as you're watching this. Okay, I've made these marks that match the y-coordinates that we see over here. And then I'm going to match this point, which is the next point beyond the last one I plotted, with the next value here. So this y-coordinate will go here, this one here, this one here, this one here, this one here, and I'm going to get a set of points that descend toward the x-axis. I'll do that off camera, but I recommend that you make your own picture and then check against the one that I make. Okay, here are my points. Notice that each of these projections is a little higher than the projection. Each of the projections I get from the second quadrant points is a little higher than the projection I get from the first quadrant point, and you can think about why that is in terms of the way these points are spaced, so that I don't quite get down to the x-axis here, but right here is the rest of that curve. And also the highest point would actually correspond to a point that's right on the y-axis here. We don't really have that point over here. The highest point of this curve is going to be a little higher than any of these points. Now I've projected these 5 points, and I've marked those projections, of course, and I've put X's or marks on the y-axis at the corresponding points here, and then I matched this point up with the next point that we haven't already seen on the horizontal axis. So here, 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 and here. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I got my here's mixed up there. It didn't seem to work out, but I think it was correct. Okay, and now you should go ahead and finish the process. What happens is we complete the cycle around the entire circle. Now I've added a point here. These points, if we follow this pattern, aren't going to go all the way around the circle. Actually, this point should be back a little bit, this a little bit more, and this about where it is. So there are some little irregularities in the way I've drawn this, but we see that we have this curve that you'll recognize as something very much like a sine curve. It's not perfectly drawn. I don't think I came down low enough here. This distance here might be a little greater than this distance here because I didn't label or didn't mark off the x-axis perfectly, but you understand that it could be drawn perfectly, and it might, it's going to look very much like this with just a couple of other characteristics. Now I'm going to go ahead and draw the curve through these points. Okay, so here in blue is the curve, and I'll call this an unlabeled or unscaled sine curve. Now I could have done a much better job, especially in the second half. The first half looks pretty good, but my amplitude got messed up on the second half. Had I drawn a good horizontal line here, the graph would have had to come down to this horizontal line because clearly y can come down this far. Up here, a good horizontal line. It seems to match pretty closely, but the graph should come up to here, should come down to here, and these points should be located a little more accurately according to the graph. But we understand how the graph could have been accurately depicted. So I'm going to draw a corrected graph. So in red we see the graph as perhaps it should have been drawn. My distance here is less than my distance here. these markings should have been a little bit closer together. This distance and this distance should be the same, but reasonably good representation of the sine graph. Now I've got another set of axes here marked off with, I think, enough points, and I was a little more careful to space them pretty much equally. And I want to use this graph to represent an unlabeled or unscaled cosine curve. Now the cosine is a lot like the sine, except that we project down to the x-axis. So each point projects down to the x-axis. So our projection lines in the first quadrant will look like this, and our values of the cosine will be these. So here's the cosine of the first angle, second, third, fourth, and so forth. Okay? So I'm going to match these values in order with the values, with these points. So my first value is up here. My second value is a little bit below that. My third value a little bit below that. And then somewhat below that. And somewhat below that. And so forth. So if I match the points up, this point goes with this value, so that's going to give me a point about here. This point with this value is going to give me a point about here. This value with this value is going to be here. This value with this value is going to be here. This value with this value, let's see, I'm getting a little bit off here. So I'm going to fix those, but you get the idea. You should draw your own sketch and then continue all the way around the circle, matching these points, these values along the horizontal axis, which represent these points in succession in this order, with their projections down onto the x-axis. Okay, I confused myself slightly. This point goes with this coordinate along this horizontal line. So this point is just a point on the graph, and then this point goes here, this point here, this point matches up here, this point matches up here. Okay, and my second quadrant points are here. And we see, of course, that I've sketched the projection lines here. Now I'm going to go ahead and sketch all the projection lines for the third and fourth quadrants and plot those on the graph. Okay, so here are the coordinates for the third quadrant in orange. So here they are. And in the fourth quadrant, we get the markings in purple, which will correspond to these markings. So here's our graph, and now we can sketch a smooth curve. It looks something very much like this. Now this curve looks a little pointier than this curve. It really isn't. It has exactly the same shape. Okay, the two curves will have exactly the same shape. It's just that this one is what you would get if you took this one and shifted it over this far, so that the peak starts at the axis rather than occurring at this point. So if you shift this graph over here, you get the graph that you should have here. It also looks a little pointier because the distance here is less than the distance here. Now, one complete cycle of a sine or cosine curve corresponds to one complete trip around the circle. Notice that we didn't quite make it all the way around the circle, but if we extend each of these graphs just a little further, it can correspond to a trip all the way around the circle. The other thing, if we take this graph and shift it 1/4 of a cycle to the left, now one cycle is all the way from here to here, so quarter cycle is from here to here, corresponding to motion on the circle from here to here. And if we shift this graph a quarter cycle to the left, we get this graph. Of course, the markings here are a little closer, so it won't look exactly the same, but if you use the same spacing of the markings, they will be identical. This is shifted 1/4 cycle to the left.